Can we go back as far as you'd like to? Because I kind of want to know how we got here. I go to your homepage today, Beyang, and I see industrializing software development with AI agents.
Yeah.
And that was not at all the headline even a few years ago. And I feel like, Sourcegraph has taken 15 years to become not so much successful, but like it's been like 15 years for you. And I would say 7 of those years may have been like really hard years. And I kind of want to just like not let the people coming to Sourcegraph today think it's been the easy road for you. Because I kind of want to know the permutations of code intelligence to AI agents. How did we get here for you?
Yeah. So first off, I think we're in year 12 right now. So
Okay.
we've definitely been around.
I gave you three.
Yeah. We're working our way up to 15. I think we'll be here for the next 50 years. So it's still early days. Actually, like it's funny that you should mention like industrialized software with agents and how that's kind of a shift. Maybe I don't know if you have like show notes that you can link to, but I can link you to a version of our seed deck back in like April, May 2013 when we were pitching the company for the first time. And it has this phrase, industrialized software engineering. And so that part of the mission has stayed largely constant. And the high level goal for us was really about basically making professional software engineering as enjoyable and as efficient as hacking on your side project is, because that was really the motivator for us in starting this company. It was the delta between every programmer starts from a point of love or delight at some point. Like the reason that you get into programming is there's this joy of creation, this spark of creation that everyone experiences at some point, whether it's at Hello World or when you first get your first working program to run and it's cool and it does something and you share it with your friends. I think everyone who's working as a programmer is to some extent trying to chase that original high. That's the dopamine rush that makes the job joyful. And it also maps to like doing useful stuff, right? Like you get joy out of shipping features that impact your users' lives and actually get used. But then you contrast that with the day-to-day of a professional software developer, most of whom are working in like a large existing code base that they didn't write themselves, that is the product of the contributions of hundreds or thousands or tens of thousands of shared hands, and that experience is very different. And what we wanted to do is solve a lot of the problems that create toil for professional software engineers in large production code bases and make it so that it's possible to focus on this like creative part of the job. So the initial way that we solved that with the technology landscape at the time was focusing on search, because that to us was the thing that we spent a lot of our time working on. We got our career started out at Palantir, but Palantir by extension meant very large banks and enterprise code bases, because that's the team that we were on. And so the core problem there was just like figuring out what all the existing code does and figuring out what the change you need to make, how that fits into the broader picture, and what sort of dependency or constraints that you're working with. And so that was the first thing that we brought to market. AI was always sort of in the back of our minds. Like I had done a concentration in machine learning while I was at Stanford. I was actually, Daphne Kohler was my advisor, and I published some research there in the domain of like computer vision. In those days, like the state of the art models weren't nearly as good. This was, pre ChatGPT, pre transformer, pre even like deep neural net revolution. So in those days, the conventional wisdom was, neural nets worked in the 80s for limited use cases, but they're mostly toy use cases, and real machine learning engineers use support vector machines and boosted decision trees and things like that. So it's a very different world, and we're always keeping our eye on the evolution of this technology. And we actually started integrating, current large language model embeddings, based signals into the search ranking starting in early 2022. And so that was something that we'd kind of been playing around with. And then, once ChatGPT landed, we were actually pretty well situated in terms of like our understanding of the technology to be able to roll that in to our platform. We launched the first sort of like context aware chat, chat that pulls from the context of your broader code base and pages that into the context window and uses that to steer the generated code or the question answering that the LLM provides for you. And that helped launch us into the age of AI, so to speak, because that was, I think now it's like, table stakes, right? Like context aware code generation. Everyone has that because everyone realizes that that is absolutely essential for making AI useful in the enterprise. But we were first to market there, and that helped us, establish our presence inside, folks like Palo Alto Networks. And, Leidos is a big, government contracting agency, and Booking.com, the largest travel site in the world. Like all these very large enterprises with complex coding needs that have adopted Sourcegraph and our AI coding system, Cody, as their preferred, essentially like platform for accelerating and automating, industrializing software development.
Mm-hmm. When you say industrializing, what does that mean to you? Like, I think I understand what that means. What does it mean to industrialize software engineering, like practically?
Yeah, that's a great question. And like this word industrialize, it's something that we've gone back and forth on because,
it sounds cool. I dig it. I mean,
I like it too. I was thinking if you go back to like 2013, I think there were a lot of people read sort of like negative connotations into it. Like what are you trying to do? Like turn every development org into a feature factory, because like that's what I think when I think of the Industrial Revolution.
Sure,
I think these days is a little bit different because the whole world is talking about like reindustrializing with all the like, geopolitical shifts going on in the world, the macroeconomic shifts. I think a lot of people are thinking about like how can we build like the gigafactories of the future and restart that process, that kind of like tech tree exploration in the West. And so now I think it carries a very different connotation. But what we meant by it and what we mean by it today is really, it started with this observation. When you think about software engineering as an industry, software engineering is actually quite unlike every other industry in the world in one specific dimension, which is every other industry, as you scale production, you get economies of scale, right? Like you build a larger factory, you can produce the next incremental thing that you're building at a cheaper cost or more efficiently. So like things get better and cheaper as you scale up. In software engineering, it's the exact opposite. In fact, like at best case, they asymptotically approach some upper bound. Worst case, and I think the reality in a lot of organizations, productivity goes down after you scale past a certain point. And as a consequence, every piece of software that becomes successful very quickly becomes a victim of its own success. Because if your software gains users and gains revenue, it will also acquire feature requests and bug reports. And as a consequence, you'll hire more developers, you'll increase the number of contributors to the code base. The code base will grow over time. You'll lose that cohesiveness of vision. And then it's like a frog in boiling water approach. Like every incremental day, you don't really notice it, but one day you wake up and the code base is a mess. There's all these constraints. It takes forever to get like a simple feature across the finish line. You wake up and now you can't get anything done. And there's kind of like two consequences to this that are very salient. One is that means that the vast majority of software that actually gets used day to day sucks, because any successful piece of software with a lot of users becomes like this. So like by almost definitionally, like any piece of software that you're using it because it was a successful piece of software. But by virtue of its success, it can no longer move quickly. The developers building it can no longer move quickly and build new things and keep that up to date. The second consequence for this is the disruption cycles. It actually occurs much more quickly in pure software than in any other industry. Like every other industry, we talk about the innovator's dilemma. It's like, okay, yeah, I get it. Like every once in a generation, something comes along down the line that disrupts, like shakes the foundation of this very industry, and then you get a whole new generation of companies that emerge. In software, it's like literally like every 5 to 10 years that happens naturally, because whatever, like you can literally see like in the past like 5 or 6 years alone, we've gone through multiple generations of like accounting software for like small businesses, right? Like every couple of years there's like a new YC company that basically does the same thing, but it's like, oh, we're gonna do it better because the old thing sucks now. And so like this disruption cycle, there's something more than the innovator's dilemma at play in software disruption. It's this kind of like phenomenon of as the code base grows due to its success, it falls victim to the very forces that made it successful, because you're going to grow the number of lines of code. You're going to add more functionality. You're going to have a hard time preserving the cleanliness and sane architecture of the original code base. And then at some point, you can no longer make forward progress, and then some 2-person startup comes down the line and like does it a lot better, and then eats your lunch.
Well, they eat your lunch for a bit, and then you acquire them, or they totally eat your lunch and they destroy you, right?
Yeah, exactly.
Sometimes what happens too. But, yeah.
Exactly. So like that's what we mean by industrialized software engineering. I think like if we can tackle enough of the toil, and also give your senior technical leadership a lever to project their vision for how the architecture should evolve, we can actually get software as an industry to be a real industry, like actually have economies of scale where things can actually get more efficient. Imagine that. It's like mind-blowing. Like, oh, things actually get more efficient as the code base grows. I think that's just like very antithetical to the way people think right now. But I think it's certainly within the realm of possibility, given modern AI in conjunction with all the other like code-based understanding technologies that we built over the years.
So given your history with machine learning way before it was artificial intelligence or AI, way back, and you're here now, you've iterated, you've sort of stuck to your guns, so to speak, of industrializing or solving this complex code-based problem from the beginning, with search, now to agents with AI. How did you know? What tea leaves did you read? Or were you just super passionate because of your time at Palantir? Because like they obviously had complex code bases, and you were like, well, this sucks. I'll eventually solve this problem. I'll just keep solving it over and over and over until we reach critical mass.
Yeah, I would say, like, I'm not going to say that I have the ability to kind of like see the future. I'm definitely not going to claim that I could see how the landscape of AI would unfold from the vantage point of being in 2013. There's certainly a lot here that is frankly just like, I did not
12
anticipate.
Years ago, so
12 years ago was a lifetime, and the technology was very immature and different back then. But what I did know, I think, Quinn and I both felt deeply, was number one, we're both really, really passionate about programming and building software. That seemed to us like the biggest leverage point. And it was really a combination of like, hey, this is a craft that I care deeply about. And I could see myself spending the rest of my life refining it and moving it forward, because it does seem, it almost rises to the level of being something like spiritually fulfilling. If you want to get like philosophical, there's this whole like, it from bit philosophy of like, what does it mean to exist? And, how does information relate to physical being and all that? And you can get into the whole discussion of like, Turing completeness. What does it mean? How does it relate to our theory of mind and the soul? Anyways, there's kind of like
do you have thoughts on that?
We can get into. I don't want to like go down that rabbit hole just yet. But like the point I want to get across here is that like we both feel that this is a really cool thing to be working in, and that's one of the things that we chose like this path as the professional path that we wanted to pursue. The flip side of that was our experience at Palantir showed us that the pain that we felt in trying to practice this craft in a professional setting is felt across the entire industry, and gets exponentially more critical the more impactful your software is, because the more impact your software is driving, the more users and revenue it has or is generating, and the messier the code base is. And so it was kind of like the marriage of these two things. It was like personally fulfilling to be thinking about like advancing the state of this craft that you feel a deep personal connection to, and knowing that it's tied to just like this huge amount of potential economic impact. And so like there, our thinking was like, with the technology that we have today, if we focus on the fundamentals, building like core technical capabilities and then rolling those into delightful product experiences, there will be like a huge company here that we could spend the rest of our lives working on.
Fun. I think it's fun, man. Wow. To have seen not the future, because you said you're not a clairvoyant, you're not a future teller.
Yeah.
But you could certainly see the direction it's going, and you said, I'm willing to keep doing this problem, keep solving this problem for the rest of my career.
Yeah.
Wow. Okay. And now we're at the age of literally AI agents. We can essentially deploy these agents similar to the way you would deploy a cron job, but now they're smart. You know, they're so much smarter now, not just a dumb cron job that requires logging and metrics and observability and failures and fallovers and system crashes. Now you've got agents that can actually do some cool stuff. You began with search. Now you're here. What do you think it is like that is attracting folks to the Sourcegraph platform today? Is it the promise of what AI can do deployed at scale?
I think there's a couple of different dimensions here. I think the most direct thing that attracts people is that we are solving for the challenges that developers face inside production code bases. So, contrary to a lot of the other kind of like AI coding things that you see, our focus has less been on like the indie developer who wants to show off, like a cool Flappy Bird clone on Twitter, which, to be frank, like it's really cool. It's really cool that you can like, one shot that now. But our mission, the thing that like gets us out of bed every morning is really to like enable the software that drives the world to be built much more quickly and much more robustly. And so that's the thing that we're targeting. And that's the reason why the customers that have chosen Sourcegraph have chosen us, because they have large, complex code bases and they appreciate the other technologies that we bring to the table that help us be effective in that setting. And that brings me to this kind of like second dimension, which is, our technical strategy here is transformers, LLMs, AI. That's all really useful. It's game-changing technology, but we think that there is a step function more capability and power you can unlock by combining that technology with some of the other technologies that we built around information retrieval, code search, mapping out the reference graph and the knowledge graph of the code. We think these technologies are highly complementary. In some sense, they represent like the two sides of what traditionally has been called artificial intelligence. Like before the current incarnation of what AI means, there was this like classic debate between the formal methods like context-free grammar, Chomsky kind of party of artificial intelligence, where everything's like kind of rules-based, and you have there's some philosophy behind it that like these grammars emerged from the mind of maybe some higher order being, and our goal is to like discover the Platonic ideal, the hidden structures that connect all these things, very symbolic based. And then on the other end is like the statistical approach, which is like we're not going to be opinionated about like defining down a complete set of axioms or rules for describing what language is. We're just going to try to model it statistically and learn it from the data. I think, the age we're living in, it clearly, we see clearly, everyone sees clearly the limitations of the Chomsky approach, and it's very apparent to everyone the advantages of the data-driven approach now with modern technology. But I think they're still actually like highly complementary. There's a bunch of productivity-oriented use cases that essentially combine a knowledge graph or some sort of symbolic representation with generative models. So like you have like the generative model providing like some notion of like reasoning, but you combine that with like a symbolic representation to make to be like very precise about how things are connected. And the composition of those two yields like way more useful use cases than if you were to just use one or the other.
Maybe for context, give me a picture, if you can paint a picture of a day in the life of an engineer working at one of these large-scale enterprises that has this complex code base issue, and you're removing their toil. What are the things that they have access to as a developer in this kind of ecosystem? Let's say Palo Alto Networks, for example. You mentioned them. I know they're a logo on your homepage, so maybe you can use them. Pick anybody. I don't care if it's them or not. Somebody. Give me the example of a developer or an engineer on a team like that. What kind of tooling do you give them, or do they have access to when they buy Sourcegraph, essentially?
Yeah. I say, so like the equivalent of day in the life for an engineer is like, what does it take to take a feature from idea all the way to like getting into production. It's like one whole loop of the software development lifecycle, which we kind of model as like this two loops that are connected. There's kind of like an inner loop, which is like your kind of read, evaluate, print loop in your editor, where you're kind of like quickly iterating on the idea and making it come together. And then there's like the outer loop, which is sort of like the ops loop, right? Like you plan out the feature, you actually write it, you push it up, it gets reviewed, it needs to pass CI/CD, it gets rolled out, and then after it gets deployed, you got to monitor and observe it to deal with any kind of like production bugs or things that emerge. So like a day in the life of like an enterprise developer or a developer working on in the context of a very large existing code base, it's kind of like you have an idea for a feature. What's the first thing you have to do? Well, the first thing you have to do is you have to go and acquire a bunch of context about the existing code base. So, in the pre-Sourcegraph world, what does that entail? It's a bunch of like grepping for stuff in your existing repository. Maybe you got to clone down a couple of additional repositories if you're very intentional about it. Sometimes people just like don't bother because they're like, it's too much work. I will just assume that this thing that I'm building doesn't exist yet, so let me just go build it. Sometimes it involves pinging your colleagues for help. So like if you're onboarding to a new part of the code base or you're like a new engineer, you're going to like go bug the senior engineer who was around when that code was written, who's very short on time and kind of crotchety because there's like 5 other people like you who have asked them a very similar question in the past like 2 weeks. So like that is a whole kind of like tooth pulling exercise. And that can take you, I don't know, like weeks, even months. Like in some of the code bases that we worked in while we were at Palantir, it literally take like months just to orient on like, hey, this is the part of the code that actually needs modifying. And there's a bunch of false starts along the way because you start writing something only to realize like, oh, you should be modifying this other piece over there. Okay, so like that's just getting to the point where you're ready to start writing the code, right? Once you start writing the code, you're in your editor. Most of the code you need to write is probably boilerplate or what we call like boilerplate plus. It's not exactly like something you can copy and paste, but you basically want to find like an existing example of using that one particular API that you need to use. And then you'd kind of like turn your brain half off and just like pattern match against that example because that's the reference point. So provided you found that example, then you can pattern match against it. If you don't find that example, then that's kind of this arduous like, hey, let me discover how to properly use this API because there's no docs on how to use it. And someone's probably done this probably like a dozen times before, but I've never done it before. So now I have to essentially go and like rediscover how to do that. So you go through that exercise. There's multiple rounds of kind of like iterating on it. Finally, you get to the point where, okay, I'm ready to like push it up. You push it up to review. Maybe there's multiple stakeholders that have to sign off on the change, right? Like there's the people you work directly with. Maybe that's part of your code review process. Maybe you also made some modifications to some other shared libraries, and now other teams that own that code have to also sign off on it. A lot of times those other teams don't necessarily care too much about the change that you're trying to land because they have their own priorities and they're incentivized to work on those and not anything else that happens in the company. So who knows how long it'll take to get all the stakeholders to sign off on that change. Or maybe you realize through the review that you get from like a senior engineer that this whole approach was wrong because you didn't do enough like search and discovery. So it's almost like this game of chutes and ladders. Like you have a potential to shoot all the way back to scratch. Like you just wasted a week, a month's worth of work because you built the wrong thing. Best case, it takes a lot of like time getting people to approve it. You finally get it approved. It rolls out to production. Maybe it breaks something. Maybe there's like a test that breaks that you didn't catch locally, and so on and so forth. Once it gets into production, there's a long tail of issues that could arise too, in terms of like it triggered some bug, or maybe there was some like security vulnerability that got introduced. Anyways, I don't have to sketch this out. It's already painful just describing this.
I'm wanting to quit right now. I'm like, gosh. Save
yeah.
me.
And this is just like a simple feature, right? Like it could be the simplest thing, like, center this div or, add support for this authentication protocol or whatever. And most of your time is spent not on thinking about the end user problem and mapping that to the algorithms and data structures that you can use. Like that's the fun part of the job. Like if I could do that all day, every day, I would do that all day, every day. But most of it is spent on like box checking, writing boilerplate, finding answers to questions that have already been answered many times before. And so like Sourcegraph essentially targets all the kind of critical pain points and slowdowns in that process. So, in the planning and search and discovery phase, like that's where people use a lot of our code search functionality. Or now we kind of have like a deep research for your code base like feature that's built into the web application, where you can ask our AI a question about the repository. It will go and do a bunch of searches and file readings on your behalf and print out like what is usually a pretty reasonable summary of the relevant files to read and how those fit to the task that you're trying to accomplish. So automatically, like that shortcuts you from having to have and wait on all these like conversations with humans that, let's be honest, like developers as a collective group, we're not like the most personable or like affable people. I mean, many of us are, but like, speaking in terms of averages, we tend towards like introversion, just like, like the spending time with our computers. Like that's why we're doing what we do, right?
Right.
Plus, even the ones that want to help, if you've answered the same question from like 3 or 4 different people in the past week, you're at the point where you're like, I just want to do my freaking work. I don't want to have to deal with any of these other like things, even if they're like reasonable requests. So like we can shortcut that process and just help you figure that out yourself through a combination of search and question answering. Then within the editor, there's all this stuff that reduces to boilerplate++, which is like in the sweet spot for what AI can do. So you tag in the relevant file, or you ask it to do a search for the relevant code snippets on your behalf, and then ask it to generate code. It generates the code. You can refine that in the chat window, apply it into the file. And that is just it adds value in a couple different ways. The first is like the raw time saved, because you don't have to manually type out all the characters for that, boilerplate++. The second thing we've noticed is that it kind of changes the psychology a little bit, because it keeps you in flow state more. Like if you don't have to page out all the working state in your brain, because now you need to go down this rabbit hole and like complete this side quest to get your feature built. If Cody can essentially do that for you, or even get you like 90% of the way there, you essentially don't have to page out the context for doing the main thing. And as a consequence, you can kind of remain in flow state for much longer. You don't have this like context switching that is very destructive. And so like that is where we probably see like an insane amount of productivity boost. I think like the number that Palo Alto quoted at us using their own kind of like internal metric or proxy for developer velocity, it was depending on which number you use specifically, is between 40 and 57%, which is a crazy speed up. That's like a game-changing speed up. And it just turns out like it just makes the job more fun too, right? Because like you don't want to spend all your hours writing boilerplate or pattern matching against stuff that's already written. You want to get to the fun start. You want to get to the fun stuff of the job, which is really think about like the user experience and then the underlying algorithms and data structures. Mm-hmm. Once you push things up to review, what we built in collaboration with a couple of our customers and is now in early access, and we're probably, by the time this is released, we'll have open access for it, is a review agent. So this is code review that kind of understands how your organization does code review. And so like the idea here is, one, we want to automate the process of code review, because there's a bunch of comments that humans don't think to leave, or just, they don't get around to leaving. There's the old adage, like if you push up a 10-line pull request, you get 10 comments, but if you push up like a 10,000 line PR, you'll just get a rubber stamp like looks good to me, because no humans. Yeah, it's too much. It's like what else am I supposed to do today other than review this PR? I got a life to live. I got work to do. Well, like an AI can just sit there and spend the time to surface like a bunch of common things that you as a human, it's probably like a waste of your time to check. Like all this stuff is like automatable now with modern LLMs. So we want to do that. There's also kind of like a psychological component here, where we don't see our code review agent as being a complete replacement for human review yet, but it's at the point where if it leaves at least a first pass of comments, number one, allows you as the author of the change to kind of iterate quickly against that. And also it incentivizes the reviewer to go in and do a more thorough review too, because the comments kind of reflect like a summary of the change itself, and just having like a comment exist on the PR, it just makes the task seem like already halfway done. And so
momentum.
Momentum. It just it leads people to like quicken the review cycle too.
Psychology, baby.
Yeah.
I love that.
Yeah. It's the combination of like, if you introduce efficiencies, you will also get these like nice second order psychological effects that further speed up the development cycle.
Right. Especially after a few cycles of this, you begin to gain some trust for the system, let's just say.
Yeah.
I don't want to anthropomorphize this thing, but we tend to. Sometimes we even say please or thank you to our agents, which is cool, whatever. You do your thing. Just wasting tokens, basically.
Yeah.
But you begin to trust it. So it's like, well, I at least know I've got to start somewhere. And so this analysis of the code review makes me feel like even if I only had to do 10%, it's better than 100%. Because now I can actually do my job today. I can do the 2 meetings I have planned and actually potentially get a review in to potentially get this into production. And that's a great thing.
Totally. It provides, it's almost like a smoother on-ramp. There's like an activation threshold you have to get beyond to get started on a particular task, like in this case, code review.
Yeah.
And without AI, it's like, oh, I'm dreading this because it's like, I need to get over that threshold. Now we can like do the first like 1 or 2 steps. And then that kind of like leads you into, it's like the same thing as like, how some writers, they say like making a mark on the page, like writing
anything.
Anything like a very bad first draft that's just like god awful, or like if an artist just like drawing a squiggle on the paper, it kind of unblocks you. It gets you past this like blank slate mental block that I think a lot of people suffer from, especially if it's a task that you associate with toil, which I think a lot of people do.
Yeah, it's like, I can't even do this.
Yeah.
I've been there. I've definitely had to do some code reviews, and I'm just like, rubber stamp that thing. Looks good.
Yeah.
Let's just let's test in production. Let's.
Yeah.
Right.
It's like, you wrote a lot of code. I think you probably understand this, much better than I do. Let's just, we'll say it looks good, and then we can both get on with our lives. I think that some version of that conversation happens all the time inside enterprises, and it happens out of necessity, but it's not good that it happens, right? Because like you have reviewing standards for a reason, and that's how bugs and security vulnerabilities and bad architecture and loss of cohesion happen.
Yeah. So is that where I think we're here because we talked about the day in the life of where do we go from after code review? Like, you're painting the landscape of Sourcegraph, what a engineer may have access to reduce or remove some of the toil in the process.
Yep. So broadly speaking, I think where the day in the life of a developer moves to is, I talked about inner loop and outer loop before. Our vision for these 2 loops is essentially like accelerate the inner loop. Like, we should provide facilities that automate boilerplate and toil inside the inner loop, such that it feels like we're building leverage around human creativity, because that is still the thing that is like, quote unquote, like out of distribution of the models, and something that is not like yet replicable with today's LLMs. And I don't see kind of like a clear line of sight to actually like replicating that. I think that is truly like the essential part of the job. That is the fun part of the job. It's like thinking up a new idea, connecting that with the user need, and then finding just like the ideal best data structures and algorithms that fit within your existing architecture to solve that. Like that is the essence of the job, and that's the thing that we want to enable people to spend like 99% of their time on, as opposed to like 1% of their time on. So we're accelerating in the inner loop, and then the outer loop, I think, is it like we want to automate as much of that as possible, because everything in the outer loop is kind of like a factory. Like, you spend all this time refining the creative aspects in the inner loop, and now the outer loop is just like, how do I get this thing that I have produced in my developer environment into production? So like the whole process of like doing the review and refining it, making sure there's adequate test coverage, like doing an automatic rollback, adding the necessary telemetry. In an ideal world, that is all within the realm of automation. It's kind of like we built this like this gigafactory in a way, where if you got it working in your development environment, everything else to get it into production should be like pattern matchable by the LLM. So in the future, I think the future that we want to work towards is like, doesn't matter what size code base you're working in. It could be the smallest thing or it could be like the largest, oldest code base in the world. You express your intent. We accelerate you getting to the experience that you want in your development environment. And then thereafter, like the machine just takes your change and lands it in production, guaranteeing security, reliability, and robustness.
Love those buzzwords. I'm being serious. I'm seeing this where you're going. I was just half joking there. That was some buzzword city there, though. I like that.
Yeah.
Robustness.
Well, that's what you want, right? Like it's
you do want those things.
Like our tagline is like, move fast but don't break. You know, like
okay, sure, I like that too.
And that is now possible. Like with today's technology, it is possible to enable like an extremely fast development cycle that augments human creativity. But you know, the things that could break your system, like a security vulnerability or too much technical debt or a bug that wasn't caught because you didn't think to add the appropriate test. Like all these things are in the realm of automation now. Like they are automatable. We just got to go and automate them.
You know what? I'm all for that because there's scenarios where developers will want to deploy code and they'll forget, oh, I didn't write or consider this one security thing that I should know about. But because I'm a human, I got limited even emotional willpower, which is a finite resource to any human being.
Yeah. Right.
We all have brains, and those brains give us a certain amount of power. Mm-hmm. Regardless of how smart you are, you could have not had your Snickers that day. So, you know, maybe you're Joe Pesci for a moment or two.
Yeah.
And you're just not, you know, you're not thinking straight.
Yeah.
Or it's 4:00 and you're trying to get this thing over the line because time, you know, and you don't write the test or you forget about a critical thing. We should have automations and checks and balances in our flow from the REPL, which you're talking about.
Yep.
This inner loop, which says, okay, now it's out of my safe world. It's out of my safe idea world.
Yeah.
My innovation world. I've tested. I've done all the things I can.
Yep.
Now it goes out to the outer loop, which is that's where automation should live because you want to confirm, is it a threat or is it an ally, right?
Yes.
Is this thing that has been done a threat or an ally? And if it's an ally, to prod. If it's a threat, let's check those threats.
Yep. That's exactly right. And I think this willpower is a finite resource. That is a really good way of phrasing it. I think I'm going to steal that. We've seen it play out not just on the timeline of like a day in the life, but like we've seen it play out on the span of like months and years. So like to give an example, like we have a customer where we partnered with them to build a sort of like code migration agent that was targeting a project to retire all these like dead feature flags that they had strewn about the code base. So like feature flags, you add them to do some experiment. And then once the experiment is over, like you decide, okay, we're going to either turn it to 100 or turn it to 0. But then like no one is really incentivized to like remove the feature flag from the source code. So over time, these things kind of like grow linearly and they add to the complexity of the code base because no one is quite sure just looking at the source, like whether it's fully turned on or not. And there's like will it branches.
It's like,
yeah, will it break? Which one of these branches actually execute, depending on like what feature flag configuration I have currently in production. So they had a migration project. The target date for the project was 10 years down the line. And literally, this is the sort of thing where like the only people with the context to lead this conversation are the very most senior engineers in your organization because they are the only ones who know the entire code base. They know all the nuances of how these feature flags can break if you remove them improperly. And they're the only ones you trust to initiate like a migration that literally touches every single repository in your code base. So it's like the joke is like, have you ever read like Kerouac? I saw the best and brightest minds of my generation. Like the developer equivalent is like, I saw the best and brightest developer minds of my generation like go insane because they had to spend 10 years of their lives working on dead feature flag removal. Instead of anything like interesting or fun, like building new features for your users or customers.
Stuff that really matters, basically.
Yeah, exactly. And so like, when we ran that project with them, it's still ongoing. So it's not through to completion yet, but we're basically able to say like 80% of these feature flag sites, you can automate like within the next like month or so. So it's kind of like, in sitting down and just like figuring out how to like compose, like build an agent to do this migration. We've gotten you within the realm of like retiring 80% of these within essentially like a month. And then the remaining 20%, they're a little bit trickier, and those will probably involve some amount of human in the loop. But already like it's like we got 80% of the way there within a month. This thing is not going to take 10 years any longer, right? Mm-hmm. And just think of the like. That's a good chunk of your life, right? For multiple people, for multiple like really, really smart people who can now like go and focus on other things that actually move the needle for the business and for the user experience.
Yeah, that really is the best use case really for automation or intelligent automation, because one thing I like about the idea of, I would say, using today's newest frontier models or generation or reasoning in problems like that is because it can run scenarios. Like it could be like, well, if it's sophisticated enough, it can say, run the scenarios if these 5 flags were removed, what would happen? Because it has awareness of the database. It has awareness of its scalability of it, what the database actually is, or what the language might be, or how it's sharded or not sharded, or like whatever the scenario is for the application. It knows that, and it can, to some degree, quantify or try to quantify some of that reasoning, so that when you get there, like the PR, you're mostly there. Instead of having to go 100% of the way, maybe only go 50%, or in this case, 80%. You've gotten 80% done, and you only have to deal with 20%. So, hey, smart fellas, smart folks, go and tackle this problem. Now you only have to do 20% of the work versus 100%. I would be so much happier, if I were that intelligent person having to deal with that issue, because it's important, but not so important that you should spend 10 years of your life doing it.
Yeah. And the remaining 20% is like the fun 20%. Like that's the interesting problems, the ones where you can actually like wear your computer science hat and, God forbid, actually make use of some of the things that you learned in college, right?
Yeah. Okay. So that's one more layer of the day in the life. This is a long day in the life. Wow. Code migration, code review. What's left? What's left in this day of life? This outer loop that you're going to automate. Is there more?
I think we've covered most of it. There's like specific pieces that we can get into, but like broadly speaking, it's accelerate the inner loop through an amazing like in-editor AI experience. Like help automate the boilerplate, help automate like the grunt work of doing simple things. And then in the outer loop, like fully automate as much as we can. So I think like the last remaining piece here would probably be some sort of like automated remediation of production incidents that happen. And I think there.
So you want to automate incidents now too?
Yeah, I think like the entire software development lifecycle, we essentially want to be the platform that performs all of that. Like we're essentially building like an agent construction mechanism into Sourcegraph, where like the code review agent is just kind of like patient zero for that. Like that'll be like a first party agent that is customizable and composable so that people can tune it to the specific needs of their enterprise. But that's just the beginning of the long and fat tail of toil that exists inside enterprises. So like the common points here will probably be things like code review, test generation, issue and incident remediation. Those probably are the most salient things for us. But then inside every org, there's kind of like a long tail of very specific things that you need to do for that organization, right? Like, if you're a big bank, you might have compliance requirements or, checks for proper handling of like PII. If you're in healthcare, there's a lot you have to do around like data privacy and making sure that that doesn't get leaked to a part of the system. Every industry has its own set of things that they need to enforce in this life cycle, and so the way we've approached this automation problem is we're not trying to build like a one size fits all thing that just does like code review. What we really want to build is like an agent authoring platform to enable our customers to go build the automations they need to build to address the toil that exists in their organization. So like
you're the runtime, they still write the
yeah,
smarts to it.
We're the runtime. We provide like the common Lego bricks and building blocks, like a common inference point, a common context fetcher, a common way of composing these agentic chains, and then their developers are essentially able to go and like with very low friction assemble these blocks into the things that target the toil that they experience.
I love that. I kind of joked earlier about, smart cron jobs. Do you feel that's kind of what this is? I mean, maybe at some level there's some things you do with cron jobs where you script something and you automate it based on certain timing and, it runs and then you observe it and did it fail or did it pass? And there's logs and there's obviously the effects of the change that you construct. Is there a day where, we will no longer write simple, let's just call them dumb cron jobs and we'll write smart ones that are very agent-like?
I think there will be. And I think the point that we want to get to, the way we've constructed our code review agent is to make it so that for the most part, you don't have to think about the imperative logic of the review agent itself. What you can do with Sourcegraph is you can define these like rules that should hold in a certain part of your code base. So a rule is just a declaration of some invariant that should hold across a certain set of files in your code base. So maybe it's something like, it could be as simple as like, hey, if you are writing the name of your company, make sure to like camel case appropriately, because a common misspelling is, people forget to camel case, and that's not good. Or it could be much more complex than that, like, hey, here's a complete style guide for writing code in Go. We've like copied and pasted the open source Google style guide because like that's treated as canonical. Make sure all the Go code in the organization like follows this style guide to the best of your ability. So like almost like every sort of like invariant that you want to describe is describable in a statement like that. And we want to give people the power to define these rules in one place and then have them be enforced across their code base. And the mechanism of enforcement, there'll be at least 3 places where this surfaces. One is inside the editor. So like make the rules part of the context that guides the generation of code inside the editor, so that you feel confident that like if most of your developers are like vibing their code into existence, that vibed code actually follows your organizational standards. So it's not going to be like, you're not going to have to rework 90% of it because it's using some framework that, you don't want to use. You want to use this other framework or whatnot. The second layer is code review. So at review time, if anything falls through the cracks, or if, someone wrote that code manually, enforce these rules to make sure that nothing gets committed that causes any of these rules to break. And then the last thing is what you're describing with like the cron jobs. Like you should just have like a multitude of background agents in flight at any given point in time, just like constantly crawling your code base to ensure that these rules hold. And if they don't, if there's ever like a point where they don't hold, push up a PR and then, automate the review of that PR so that like a human can come in and be like, okay, yep, you checked the right things. This looks good. And like you've added the appropriate unit test to make sure that nothing breaks. Looks good to me, to ensure that those invariants hold. I think the combination of these 3 methods of enforcement will allow your technical leadership, like the people who carry like the architectural vision of the code base, to really enforce consistency and coherency across the entire code base, not just like catching the typo things, but like you can actually describe like architectural constraints. Like, this component, if it talks to this component, should go through this interface because that's the intention of the architect. It's very important that we maintain this interface boundary because that allows us to keep the code like clean and like changeable moving forward. That's the sort of thing where like without this system, without AI, it would have been like a losing battle because like you only have a certain number of like senior developer hours in the day, and at some point, some PR is going to sneak past the reviewer because they got other stuff to do, right? And then at that point, you've broken the invariant, and then things slowly decay over time. And that to us, to get back to the industrialization point, that's a linchpin of being able to make coding a truly industrial craft. Another point of reference for us is if you've ever read The Mythical Man Month, like that's the classic.
I have not.
Oh, you haven't? Oh, you got to read it.
Oh man, I'll put
to
it on my
me,
list.
the book was written in the 70s about like challenges that developers faced building like mainframe software, but it is still like it's like 98% applicable to the way development currently works today, which is like the thing that holds software back and prevents these actual economies of scale from being realized is the loss of architectural vision and coherency that occurs when you scale up the size of the team working on the software and contributing to the code base. And so like this is a perennial problem that has plagued software development since the mainframe software of like the 60s and 70s, which this book was written about. But the same general principles apply today. With our system, this like system of rules and invariants enforced through AI at different parts of the SDLC, our mission, our vision here is to give the like architect of your code base a lever by which they can enforce the constraints and architectural rules that must hold in the code base to preserve the overall kind of like cleanliness and design of the code base. Like now, for the first time in history, I'm not saying it's a solved problem. We're still in the process of solving it. But like now, for the first time in history, we have line of sight to solving that. And I think if you're playing around with these technologies and using them day to day, you can see how we get from here to the point where people can like define these rules in one place and just constrain and control the evolution of the architecture as code grows. If we can do that, then we basically solve the fundamental problem of the Mythical Man Month. And that ushers us into a new age of software development. We're literally transitioning from like cottage industry or like artisanal craft into actual industrial processes where we do have economies of scale and we do have efficiencies where the team can actually, not get slower, but actually get faster the larger the code base becomes.
Yeah. I'm seeing this world. I mean, are we there yet? Let's stop for one second. Are we there yet? Not quite.
No, not quite. And we're in the midst of building up like, this gigafactory.
Yeah. Okay.
For us, it's really about like building these factories in collaboration with our partners. So like one of the things that differentiates us is like, first of all, we're thinking about this problem at all. And second of all, we can sit down with like the technical leadership at the booking.coms of the world or the Palo Alto networks of the world and make this system work well for them, because building the gigafactory is very different than building something that works inside like a small code base with a couple of contributors. And I think, the low hanging fruit is definitely like the small code bases, which is great. Like I'm glad there's like a bunch of people working on that and making that better. But I think where we see a strong alignment with our mission and what we want to do in the world is really enabling software development to go much more smoothly and quickly inside these large, like industrial scale code bases.
Well, what the picture it seems you've painted, if I can just analyze a little bit, is if I'm an IC in any of these organizations and they're, like you mentioned, there's a certain interface, I may have to write code to, it always has to go that way. So the agent that may confirm that that's a truth or not for my code base.
Yeah.
When I deploy code, if I can do my REPL, my inner loop, my creativity, and I have insurances outside of it, like no matter what I throw out there, outside my circle of trust, let's say within my own brain or my own team's brain of innovation, creativity, moving the ball forward, if I know whatever bounces back holds true against rules that my organization trusts, holds near and dear, is orchestrated and designed by the most thoughtful people. If I can be creative within confines, it's like you still have constraints, but now it's not rogue because you can add more and more smaller teams to be creative and to throw things outside their circle of trust and get bounced back. Against this wall, so to speak.
Yeah, and the robots should be able to handle somewhere between like 90 to 100% of the back and forth, right? Because like before, this would be very painful because like you push up your new feature, you're all happy about it, but then some like architects would be like, no, like it violates this constraint, or like this part is not clean. You have to go and do a bunch of rework to fix it. And then you push it back up again, there's more comments, and this process just drags on, and both sides get increasingly frustrated because finite willpower at the end of the day. But now you can have the robots handle like the vast majority of the back and forth, and so now it's like you focus on the fun parts.
Worst case, you're mad at Cody or whatever you name the next robot, right?
Yeah, and if you get mad at Cody, the brilliant thing is that like, hey, just tag in Cody to go address Cody's comments, right?
Nice, yeah. You'd mentioned in the pre-call specifically some things you do for enterprises and government agencies. What is it that those, we probably talked about some of it, but what is it that those organizations need that has only been uniquely designed and engineered by Sourcegraph to help them do better?
Yeah, so there's two things here. One is the context awareness, like building that in as like a first-class citizen. I mentioned that we were first to market for that, and we actually have a way of delivering that really effectively into the enterprise. Like Sourcegraph has been self-hostable for many years now because a lot of our early customers were very large enterprises. And so we've built all this DNA around delivering the best context for human developers in the form of code search and code navigation into all these different deployment environments. And we can essentially offer those same context vectors as a kind of like game-changing tool or capability for LLMs as well, like any sort of AI code generation or question asking. The other facet of this is just the security and compliance requirements that a lot of these larger enterprises have to comply with or are constrained by. So in terms of like being able to deliver something into a purely self-hostable environment, I think we're basically like the leader in being able to do this. Like even Microsoft or Copilot, with all their kind of like enterprise branding, there's still components of their infrastructure that have to be tied to their cloud. And that essentially rules them out for a lot of, frankly, like the largest software engineering organizations in the world. They're ones that you haven't heard of, but they're literally like powering half the economy. And they have very stringent security and data privacy constraints.
So you can self-host everything we talked about today.
Yes.
And it's by design. Like that's not obviously by accident, because you wouldn't do it by accident, because that's very hard.
Yeah.
It's very hard to self-host. So does that make it challenging to build Sourcegraph to sort of have two deployment targets, or I guess infinite, really, technically?
Yeah.
Because you've got your own cloud, I'm sure, which I can go there and be a cloud customer or you're hosted it versus my own hosting.
It's absolutely a challenge, and it's something that has slowed us down a bit. Like the in-editor experience, I think we've had a bit more challenge in pushing that forward than we would have. Like we ideally would have liked to move faster on kind of like the in-editor UX, but because we're targeting like a variety of different editors and deployment constraints, that has like constrained what we've been able to do there to a certain extent. But I think now we're at the point where we've kind of like figured out all the most important parts for how to deliver this into large scale organizations. And so now revisiting like the core UX, I think we feel pretty good about the degree to which we can implement all the things that people want in terms of like AI code generation and agentic automation within the editor. But it does remain an ongoing challenge, right? Like it's not a trivial problem by any stretch to solve. And it's something that, a lot of the like upstart people trying to do things with like code plus AI, they have not solved yet. And I think will take some time for them to solve.
Mm-hmm. Is your most popular editor VS Code, or your target where a lot of the generation is happening?
I think probably by usage numbers, VS Code is the most popular, but we have a ton of JetBrains users as well. And we also support Visual Studio and Eclipse, which, it might be surprising to some folks in your audience, but like there are like very large government agencies that are still on Eclipse, and they are constrained by factors beyond their or our control. And being able to deliver this into that editor is kind of like game changing. We're literally bringing like the latest technology into a very kind of like old school legacy editor, and it just like it completely upends the speed at which they're able to move inside those code bases.
I know that one of your teammates, I think, went to Zed. I'm thinking, like, why wouldn't you just build your own editor or acquire one? You know, like, why don't you just acquire Zed and make it easier?
Yeah, so
and that's deploy the best editor ever out there.
Yeah. So I think the teammate you're talking about,
you can mention his name if you want to,
is Thorsten Ball.
Yeah.
He's awesome. He actually just bounced back, actually. So he recently
I saw that.
he rejoined us.
That's why I felt comfortable mentioning his name in this scenario, because he's back again.
And look, he's awesome. I think, look, I love the Zed folks too. Like we've had one of them on our podcast back in the day. I really love what they're doing. I think it's a fantastic editor, and I sincerely hope that it becomes like really big. I think they have a unique approach here. They're not a VS Code fork. They're really kind of like rebuilding an editor up from kind of like first principles and focusing very much on performance, which I absolutely love to see as a developer. And yeah, like I hope they succeed. Like I would love that to be like an editor that I could use someday. As far as like our business is concerned, like the way we view the in-editor experience is, I think like maybe this is a difference in our vision for the world compared to like some of the other players in the space, but we don't think that there's going to be a single code editor that is universally adopted for every language and every platform in the future, much less like a closed source one. I think like open source in the editor remains important because it's so kind of like near and dear to the inner loop and the individual developer workflow. And so when we think about like the type of in-editor coding experience that we want to enable, we start from a point of wanting to deliver that experience into the best editor for your particular ecosystem or your platform. I guess like that's somewhat of a contrarian view these days, because there's all these like VS Code forks floating about that frankly speaking, like they've done a really good job on some of the core UX and kind of like push the frontier in terms of showing people what's possible with AI. But the long story, I guess the short of it is, for us, we are thinking about building for the large code bases that make the software that power the world. Those are multi-editor environments. They're also environments where it's not just the context inside your editor that matters. It's actually connecting it back to the overall context of your organization and the entire code base. And so the way we're approaching about building for the editor is to bring the best AI UX in the field in a way that feels native to each of the editors that we support. We eventually hope to support all the editors out there.
That makes sense. I mean, in essence, what you said was go where the developers are, right? Versus force them into your stadium. You're going to all stadiums.
Yeah.
A world tour.
Yeah, basically. And part of this too is like when we look at the UX of how people employ AI inside their editor today, we don't see anything that fundamentally requires a different editor, especially looking forward with like model capabilities evolving as quickly as they are. I would say our point of view is that every 6 to 9 months, there is a step function increase in LLM capabilities where the assumptions that you had to build around in terms of like what sort of like user experience you enable, or what are the facilities that you have to build around the model, those entirely change every 6 to 9 months, because the kind of like gaps that you had to fill because the previous generation of models couldn't just one shot the thing that you're trying to do, or couldn't just like find the right tool. Those constraints no longer exist. And the constraints that you have today in another 6 to 9 months won't exist either. And that has been the pattern since the release of ChatGPT. So like we've seen a progression of these step function models. Like, there was GPT 3.5, GPT 4, then Claude 3.5 Sonnet, and now 3.7 Sonnet. I think each of these has moved the needle in a way where like a lot of the prior assumptions and constraints no longer hold. And so when we look at the ideal editor UX today, looking forward, we actually think there's a very clean way to integrate AI generated code into every editor that doesn't involve a lot of like extra UX Chrome or things. It's mostly just relying on the model reasoning capabilities, providing it the right set of tools in the form of both like local tools and tools that call out to code base wide context fetching, and then having a like constrained set of hooks into the editor. Like, how do you render a proposed diff into the editor buffer? How do you render an edit suggestion into the editor? These sorts of things, which, look, you have to build those integrations so they work well, but it's a very narrow set. It's a narrow API that we think we can implement really well. And I think the thing that we'd like to build is kind of like an AI kernel that you can port to every editor and maybe even to the command line, because like it's a lot of the same usage patterns that you see there, where it's like you want to describe the change that you want to see what edits are proposed, you want to accept those, and then you want to continue doing what it's doing, but keep you in the loop as to like what it's doing and how that affects the rest of the code base.
Yeah, there's a certain framework that happens no matter what. There's certain interfaces you expect.
Yes.
No matter if it's your Z editor, because I'm telling you to acquire it, or suggesting that you should, or every editor out there that developers use, no matter where it's at, or what even legacy ones, or I suppose lesser used. I should not say legacy, like Eclipse. There's still lots of folks using Eclipse for good reasons, I'm sure. For good reasons.
If you think about like, there's another analog here, which is like, a couple years back, a big innovation in the editor space was the introduction of the language server protocol, LSP, right? And that showed that, hey, you didn't have to build bespoke code navigation for every single editor. Before that, it's like, I want to use this editor because like some hacker out there spent, night and day over the course of like weeks or months hacking into, this compiler to rip out the internals. And now like that editor supports really good go to definition for my language of choice. LSP came along and basically said like, look, fundamentally, what do you need to do? You need to go to definition, you need to find references, and then there's kind of like a short list of other functionality that's really useful to have. We can abstract that away and make that feel native in every editor so that you don't have to reinvent the wheel. And I think something like that is possible with LLM-driven code generation.
Let's dig into, I think, something that you have a unique perspective and vantage point on, which is the frontier models. What is being used, what's being deployed. You obviously give access to all the frontier models from Claude to Sonnet, all the different ones. What is most useful to developers? Do you offer them all because they all have unique perspectives on code generation? Is there one you particularly like best? What are you hoping for in terms of frontier models, like open source, not open source?
Yeah.
Are you a DeepSeek user? I don't see it in your list.
Yeah.
That's a swath of things. Let's go from there.
Yeah, so the landscape today, March 5th, 2025, is...
could change tomorrow.
It could change tomorrow. By the time this comes out, maybe it'll be different. But that's why I say the date, because, I want to make sure that I'm pegging the statement to a specific point in time. The preferred model for our user base is the Claude Sonnet family of models. So we have a lot of users still using 3.5 and a lot of users using 3.7. I think there's been some interesting discussion around like 3.5 versus 3.7. For instance, like I saw a bunch of like Cursor users tweeting that like 3.7 didn't feel like a big improvement. In some cases, like worse than 3.5. For the Cody users, it's actually been the opposite. And I think it's actually because Cursor has done more legwork around like optimizing their prompts around 3.5. Like we've done less of that because we've been more model agnostic in our approach. And what we found is 3.7 just has like certain capabilities, especially around tool use, that have gotten like substantially better. And so that's why we're building, like the future of Cody is really going to be built around the set of capabilities that are now unlocked with 3.7 Sonnet. I think we also see a lot of usage of kind of like reasoning oriented models for like trickier problems or problems more around code based understanding, where like a non-reasoning model might make a hallucination or an incorrect interpretation, like a shallow interpretation of some set of context. So we do see some usage of like the reasoning based models, like O3 Mini and things like that. DeepSeek is really exciting. I actually think it is available now in the model dropdown. Okay. Yeah.
Marketing says no, but I'm not inside the application. I'm on /Cody of sourcegraph.com and it's not there. So
yeah. We probably need to be inside the editor. DeepSeek is also really exciting because it's, I think, at the frontier of the open source models. And like the open source models are also very interesting to us because one, it's like, we always like supporting open source, especially at the model layer. That makes it attractive from a variety of different points of view. I think like Llama is also like an awesome family of models that is available through Cody, and that we also see like a lot of future potential around. The second reason why DeepSeek and Llama are very exciting is their fine-tunability. So there's a bunch of like use cases inside the editor, like suggesting the next edit or applying a proposed change into the editor, where these open source models provide a very good foundation for tuning a very fast model that's specifically targeted at those use cases, where like the use case is very latency sensitive. So we want to preserve the context awareness and preserve the intelligence as much as we can. But since it's constrained to the specific use case, it doesn't have to have as much of the general intelligence that like a frontier model has. But because we have relaxed that constraint, we can push the latency and cost down to the point where it feels more instant.
Can you explain to me how, or is this proprietary, how you interact with the various models? You mentioned you're agnostic, so I imagine just like you want to go where developers are, which means whatever editor they're using. Yeah. So that means that you've got an agnostic approach to how you gain your context via Sourcegraph and apply that to the age or the model that's going to give back the generation or give back the reasoning. Can you explain to me how that works from prompt to Sourcegraph context to the model and back again?
Yeah, so model choice was something that we prioritized as like a key original design constraint around Cody. We basically made the bet that the model landscape would shift
constantly
and evolve. And I think that like prediction has panned out.
Yeah.
And so we never wanted to be like overly constrained to one specific model or the current generation of models. And so we architected the code in such a way that we could easily introduce new models and also customize like the prompts that we use for each model, so that like we can use the best prompt structure given each new model that comes along. And so because of that, one, it's advantageous if you're a user, if you want to play around with the latest model on the day it drops. Most of these models we make available within like 24 to 48 hours for users of Cody Pro. And then if you're an enterprise user, this is also helpful because sometimes you have constraints around which model you can use. Like there's a bunch of enterprises, for instance, that don't want to use DeepSeek because the progeny of that model just rules that out. Yeah, for whatever reason. And so we don't have to use DeepSeek in that case. Some people cannot use Anthropic or OpenAI. Like maybe they're tied to like Azure OpenAI or AWS Bedrock. So they're constrained to the models that are available on that platform. And we can easily, make the functionality available given their model constraints.
Can the person or persons over the org, Sourcegraph org, I suppose, can they delimit or remove the opportunity to even select a model they can't use?
Yes.
Oh, that's cool.
You can do that at the admin level.
That makes sense.
Yeah.
That's the way to do it, man.
Yeah.
Any plans to? Is there any more on that front? Did I cut you off?
I mean, I say we partner very closely with all the various frontier model development shops. I obviously can't share anything that's not public, but I think we're seeing a lot of exciting things coming down the pipeline, and so we're kind of like building our future and editor experience with an eye towards where we see the puck going in terms of model capabilities, which is very exciting for the future. I think the thing that I'll say here is that like AI has already gone through two to 4 mini disruption cycles. Like we typically think of disruption cycles as being on the order of like years at least, right? But the shift in the step function improvement in model capabilities that we see every 6 to 9 months or so essentially like resets the game for what the ideal UX is at that cadence, like every 6 to 9 months. So, you know, rewind to the ancient age of
1 year ago.
1 year ago, 2023, right? 2023, Copilot was king. They seemed unassailable. Everyone wanted autocomplete. No one even cared about like chat or context awareness in that chat, right? Because autocomplete was where it's at. You want it to be fast. You want it to be snappy. You want it to be like a little bit context aware, but people just wanted it to be fast, right? Like, and that was like the UX paradigm that was dominant at the time. And then in 2024, like the paradigm completely shifted. I think it first shifted with GPT-4, where like, okay, that was a model that had a step function improvement in its ability to like one-shot applications. So now it's like, why would I sit there like auto-completing stuff when I could literally just like generate an entire mini app from scratch? It also got a lot better at incorporating context. So now you can do kind of like context constrained code generation, which we deployed, and it had like massive success in the enterprise. But then there were still certain things that it, you know, couldn't do well. Like the code was often sometimes broken or didn't quite compile. And then when Sonnet rolled out, that was like another step function. It's like, oh, now all of a sudden, like these things that were kind of like just beyond the capability are now like firmly within, like I can trust this thing to reliably, you know, emit JSON, for instance. Like that used to be like, that's a solved problem now. Like people used to write, you know, entire thought pieces around like, how do you constrain the model output to produce valid JSON? Like these days, it's like you don't even think about that because the model has been trained to treat that as a solved problem. So, and I think now we're seeing it in terms of like in-editor agents. Like that is the future, and that's what we're building towards. You know, a year ago, I think if you're pushing agents, you know, there were certain like companies that were, you know, we're going to build like the agent that like eliminates the developer entirely. I think now people recognize that as they were kind of like selling beyond their existing capabilities at the time. It made for a great kind of like marketing moment, and they got their name in the headlines, but there was a disappointment in the actual product experience. Now with like the newest set of models, we're seeing this approach just like this is kind of like the new paradigm. That's what we're building for. We have kind of like a wait list of people who want to get access to the thing that we're currently building in collaboration with a lot of these like frontier shops, and it works very well in large messy code bases as well, because again, like that's the problem that we're solving for. And so I think the future is very bright, and I don't, you know, at some point I think we might plateau in terms of model capability, but at least, you know, for the past 2 years, there's just been this regular cadence of step function improvements and model capabilities. It's just been really exciting to see that and sort of like ride the wave of the development and maturation of this technology.
This wait list, is it a secret? These details behind it? Can you enumerate at all?
When is this episode going
Tease
out?
At all?
So
next Wednesday.
Oh, next Wednesday. Oh yeah, it's closed right now, but I don't know. Like DM me on Twitter. We're playing this like very ad hoc right now, just because I don't know what we've learned over time is that like new kind of skunkworks projects like this, it's never good if you make them like overly formal too quickly. So we like it to be scrappy. We like it to be just like a handful of devs kind of like locked in a garage like environment of some sort, just like hacking on stuff. But you know, I think we'll have more to share here soon.
You've already long betted on the UX inside the editor, so that's not changing. It's an improvement, or maybe something like that with a particular model or model developer.
Yep, basically. And so like the way we think about it is basically like this. What we are doing, what I'd recommend like other organizations do, is you want to position what you're building inside your organization to ride the wave of model improvements. And so what that means is like you have to just assume that the reasoning capabilities and the latency will continue to improve at approximately the same clip as they have been. So what do? Like to a certain extent, you have to hack around the existing limitations, but you don't want to invest too much in those because another 6 months rolls around and like those are kind of like, obviated. I think where you do want to invest in right now is very high quality tools and capabilities that can be composed with the rapidly advancing reasoning capabilities of frontier models. And so it's essentially, for us, it's kind of nice because we've essentially been building these tools the entire time at Sourcegraph. It's like we're building tools to help human brains explore the code base effectively and build up a working understanding of it and write effective code pattern matching against the existing patterns and validate that that's correct and consistent within the style of your organization, the rules in your organization. Now, increasingly, we're seeing like the LLM brain being swappable in for the human brain in a growing number of tasks. Every kind of advancement in reasoning capability or context awareness or pattern matching capability advances the frontier of where like an LLM serving as the coordinator of these tools, the orchestrator of these tools, can now automate something that previously like a human brain would have had to attend to. And so the way we view it is like we are really investing in the tooling ecosystem and infrastructure that we build around the model with the assumption that like all the frontier labs are going to be pouring it seems like all the money in the world, right? Like billions, if not trillions of dollars into pushing the advancement of this reasoning technology as far and fast as they can. So like that's the big wave right now. And the way we're designing our platform is to just like provide the best tools for accelerating and automating the software development lifecycle under the assumption that there's going to be kind of like a, maybe Moore's law is not the right analogy here, but there's I think you can assume some pace of like advancement in reasoning capabilities for at least the next, couple of years.
Mm-hmm. Yeah. Well, I'd imagine that you're getting this access and you can call these folks partners and work in this degree because Sourcegraph is a deployable target for all of them, essentially. They can't assume that I go to the cloud website or to the OpenAI website or to my own way, is that Sourcegraph's Cody is just one more way to deploy and distribute those LLMs and those reasonings, so to speak, to developers where they're at, I'd imagine that's probably true. Can you speak to how saturated your user base is with, like, of the developers who are developers, in quotes, to Sourcegraph? I don't know what you call your people, so to speak, your user count. I don't know. I'm trying to get your lexicon in my brain.
Yeah.
Do they all use Cody? Is everyone using Cody? Is Cody, one of your most successful products?
I would say Cody has been, I think, by far and away the most successful product that we've shipped, with code search being kind of like a close second. If you track by kind of like user count. If you track by revenue, like we have other features that are drive a lot of revenue as well, like batch changes, which is the large scale refactoring thing. It's very, very useful and very, very valuable for large messy code bases. But in terms of like overall user count, developer count, I think Cody has been extremely successful. It's not there's not 100% overlap yet. Like we do still have some people using code search who don't use Cody, or some people using Cody that don't use code search. But we see an increasingly number of people kind of float between kind of like generating code with AI to like looking up context myself to make sure that I understand like what the code actually does and what APIs it's using, et cetera, et cetera. And yeah, I would say like we are seeing an increasing amount of like people starting at one point and getting pulled into the other. And, for that reason, we've also made this like AI question answering interface available in the web application, where like you can go to any repository in the Sourcegraph UI and ask questions when you're viewing the code in the Sourcegraph web application. So just trying to like connect the dots, right? We kind of like developed Cody as like a separate independent thing, but increasingly our user base is really pulling us to integrate it into kind of like the unified source graph experience.
Yeah. It's hard to see from the outside how Cody is independent, because you can go to, slash Cody, which is what it is, but, the headline does not say by Cody.
Yeah.
The headline, I don't even know what it says, but it doesn't say that. I think it's like the enterprise AI code assistant,
Yes.
And then somewhere in the line, it's like with Cody, you can do X. There's not this named thing where it seems like it's a standalone product that also is deeply integrated.
Yeah. I say candidly, like our marketing messaging hasn't been the greatest. I think there's some confusion over like what the overlap is.
Very much, yeah.
And that's something that we're trying to address. I think one of the challenges for us is like we built so many capabilities around like accelerating and automating the SDLC over the years that there isn't like a succinct way of describing what the whole platform does other than it accelerates and automates your SDLC, especially if you're in a large code base. But that's not as punchy.
What is
as
SDLC?
Software development lifecycle.
I thought so, but I just want to make sure. Unless it was something on the inside. I'm like, what's SDLC? Okay.
Yeah.
What's left unsaid? I know that we've talked a lot. You've got short amount of time. You got some other places to be. What can we say in closing? What's on the horizon that no one knows? Or knows less of that you can mention in the closing?
I think, for us, it's really mapping back to these two loops, like the inner and the outer loop. So expect a huge like overhaul and improvement to the in-editor experience that we provide around like what the AI can do when you're coding, when you're vibe coding or when you're like writing code in your editor, and expect an increasing amount of automation around that like long and fat tail of the outer loop of the SDLC. And I think like philosophically, the way we're trying to build this is we think the in editor should be as open and adaptable as possible. So open source, cross editor. These are the things that we value as developers. And I think, pre-AI, like every developer would say that they valued that. I think the first generation of AI coding assistants has kind of muddied that a bit because a lot of folks have kept their solution closed source. But we think the end game here is going to be open, and we aim to build in the open here. And then in the outer loop, I think the way we approach the automation here is that we're not trying to anticipate all the different ways in which we can compose, the different building blocks. We want to build the building blocks and use those to provide, a handful of first-party automation tools like the code review agent. But at the end of the day, we want to hand this platform over to our users, who are developers after all, to go and like combine these things into the things that like tackle the things that eat up your time and produce toil for you today. So like that is our philosophy. We've been doing this for over a decade now. So we've kind of like fully internalized the challenges and what a solution needs to be in order to work in the context of a large messy code base, as well as how to deploy that solution into your environment. And like I said at the very beginning, like we chose this domain because we felt that easily spend our entire lives working on this. This is where our passion is. And, I see a long and bright future ahead for us as a company, essentially bringing all the biggest, most important code bases in the world to the point where they actually can achieve these industrial economies of scale.
Industrial economies of scale. I love that. I mean, I think it sounds cool.
Yeah.
I'm excited about, just the economies of scale really at that point, because like it's generally been harder to add more developers to a team and get better.
Yeah.
You might go faster, but not necessarily always better. And it's not their fault.
Yeah.
Necessarily because of willpower, right?
Yeah. Yep.
Or just like human nature, like I don't like you or you don't like me. It's hard to work together.
Yeah.
Or I had a bad day or my weekend sucked.
Yep.
Whatever makes you less effective or productive.
Absolutely. And you should absolutely go read the Mythical Man Month, because what you just said there is kind of like the core thesis of the book. It is adding more people to a software development project makes it take longer, which is the truth that has held true since the dawn of software development. It is the fundamental challenge that we aim to solve. And it's frankly like the thing that's holding back the quality of most software in the world today.
Very cool. Thank you, Beyang, for sharing the depths of Sourcegraph and your journey. It's been fun. Thank you.
Absolutely. Thanks for having me on again, Adam.